I wanted to go through a problem for finding the derivative with the definition of the derivative, which is kind of an uglier problem. Let's take a look. So my difference quotient is, of course, f of a plus h minus f of a over h. You can tell this is going to get a little bit long, so I'm trying to keep it all on one board. What I need to do then is substitute in a plus all these guys, right? So I want to substitute in a plus h here for every x in my original function. So I'm going to have a plus h over 1 minus 4 times a plus h in parentheses. And then the second one is f of a, so minus a over 1 minus 4a all over h. Now then, I'm just going to stop for a minute and make a quick point. Any of you who have had some calculus before at this point are like, or even before when you saw the problem, you're like, I don't want to do that. I don't want to deal with this. This is awful, right? Nobody wants to deal with this. Well, too bad. So what I mean is we will shortly learn how to use the derivative rules to take the derivative of this in a much easier way so we don't have to use the limit definition. So you'll have to do this a couple times in this chapter, and at the end of chapter 2, once we get into chapter 3, we'll learn easier ways of doing this. So some of you already know those easier ways because you've had some previous exposure. Still, in this section, I expect you to do it with the limit definition, so I expect you to work this out this way. Because it's important to understand where it comes from and what it really is. So that is kind of a key point, a key part of what you learn in Calc 1, is really understanding, okay, what is the derivative and how do I get there, even from the definition. And so on the first test, which we'll have before we go into chapter 3, I'll expect you to take these derivatives with the definition of the derivative. And then later on, you can do it with the derivative rules. You can do it the fast way. On the final, in this class, there's always at least one problem where they say, do it with the definition of the derivative. And if you do it the fast way and don't do it with the definition of the derivative, you will not get any credit for that problem. So it is important to know how to do these. Okay. So that said, I think this is a little bit nastier than something I might put on a test. So at least that, right? So what am I supposed to do with this? I mean, it's not awful, but it's just not very pleasant, you know? What I need to do is the same thing we did on that worksheet the previous week, where we had a compound fraction, something like this, and now what we want to do is make a common denominator. I'm going to see if I can fit it up here, so I don't, and I think I should be able to, because our common denominator is going to be that guy times that guy. Now for the top, of course, it's going to be this times this piece. So that's going to be a plus h times 1 minus 4a. And then I'm going to subtract a times this piece. Oh, I hope you guys can read this. It's really squashed in there. Okay, I hope it's okay. So now I'm going to work that out a little bit. I've got 1 over h, and then I'm just going to leave the bottom like it is. But we have to do some work on the top. So I'm going to multiply all these out, and I have to be careful about my signs, because if I mess up my signs, things aren't going to cancel out right. So then I'll get the problem wrong and it'll be even worse. That would be terrible. After this work, right? 4 minus 4a squared minus 4ah for that first one. And the second one, remember, I'm multiplying all those through by negative a, so I'm going to get minus a plus 4a squared plus 4ah. And now all of a sudden, I feel a little bit better about my life, right? Because these a's cancel out, the 4a squares cancel, the 4ah cancels, and this doesn't look like it's something so hideous anymore after all. Because all that mess, the only thing that's left over is this term is h. And then on the bottom, I have 1 minus 4a minus 4h times 1 minus 4a, which, as I said before, I did pull this negative over there, and I did that precisely because when I make a common denominator, it's just easier for me not to have those parentheses. But you'll notice I didn't bother to multiply these guys together. I could have, it was not wrong, but it just doesn't help me get my goal, which is this. Oop, no more h's, h cancels out. I now have the limit of something I can take the limit of. It is this. And what happens when I take h to 0? Well, this guy just goes to 0, and I end up with 1 minus 4a times 1 minus 4a in the bottom. So I end up with 1 minus 4a quantity squared. That's the answer. So it worked out. It was a little bit of work to get there. It wasn't the worst thing in the world. You can imagine if the more constants I have, sometimes if there's something squared or whatever, the more complicated, the more algebra is going to be required to get myself to this magic point where I can cross out those h's and then just take the limit. But this is an example of one which is, somewhat, do a little bit of work to get there.